everyone, and welcome back. Today I'm going to be going through how to calculate a bond's clean and dirty price using a financial calculator. So what we're going to start off with today is a bond quote from the Wall Street Journal where we're given a coupon, a yield, and the maturity. We're going to assume a settlement date of 2 days from the day the article was posted. And what we're going to do with that is we're going to calculate a clean and a dirty price. We're going to be using two different methods. So the first one is using these time value of money functions across this main menu. In doing that, we're going to do a two-step process where we're discounting the coupons back. Then we're going to determine whether what we're calculating is the clean or the dirty price. It'll end up being the dirty price. Then once we get the dirty price, we're going to figure out what we need to do to get the clean price. Then next up, another common way to solve these problems is using the bond function on these financial calculators, which is just above the 9. So second, we're going to solve it using the bond function. And again, we're going to see whether or not the result it gives us is the clean or the dirty price, then determine how to calculate the other one. So I hope you find this video helpful. All the video breakpoints will be listed down below. That way you can fast forward or rewind to any portion of the video you're looking for. And also you're going to find this full PDF version that I have written out, all the notes I have here, linked down below as well. So first, let's look at the bond we're evaluating today. So this is a quote from the Wall Street Journal. And in this quote, what they give us, high yield issues with the biggest price increases. These are all high yield bonds and they're all corporate bonds. So that tells us our day count convention for these bonds is going to be 30 days per month, 360 days in a year. And that's going to be important when we move over to our calculator and we're calculating the number of days. So let's just price this first bond here, the Royal Caribbean Cruises. So it says there's a coupon of 7.5%, a yield of 13.51%, a maturity October 15th, 2027, and then the current bond price says $78. So we're going to be trying to match this 78, and you're going to see that we can get really pretty close to this. A few reasons why our answer may not perfectly match this one. First, it doesn't tell us when the settlement date is here. Typically for corporate bonds, the settlement date is 2 business days past whenever you buy it. So this Wall Street Journal was on Friday, let me get the date, July 29th, 2022. So likely the settlement date would have been this upcoming Tuesday. And then also you can see that our yield is really just rounded to 2 decimal places. So we lose a lot of accuracy there. So let's try pricing this bond and see if we can match this $78. So for this example, I'm going to assume my settlement date is 2 business days after the day this information was provided. So I'm going to have my settlement date as August 2nd, 2022. So all of this information was given essentially using bond market conventions. So the coupon rate, that's an annual coupon rate. And what we need to do from this is we need to figure out a semi-annual coupon. Then for the yield, this is given as the bond equivalent yield. So that is our semi-annual yield times 2. Maturity, October 15, 2027. And then again, the settlement date is 2 business days from when that article was printed. So now let's do this solving it first using what I call the two-step method. And what this two-step method is let's start with the timeline. So on our timeline, the next coupon that this bond is going to pay out is going to be October 15th, 2022. The last coupon that they paid out was April 15th, 2022. So we're essentially buying it right in between these 2 coupons, right? We're currently August 2nd, 2022. So after this partial period, they're just going to keep on paying their coupons at semi-annual frequencies all the way across our timeline. Then at the end, we're going to get our last coupon payment. And then here, I'm going to use a face value of 100 just so that we can compare it to the Wall Street Journal quote, because all of those quotes are given as percentages of face value. So 100 is easiest to use here. So the first thing we need to do is we need to figure out how many full periods we have and then what fraction of a period we have right here at the beginning. So to figure out the number of full periods that we have, I'm going to use the date function on my financial calculator. So this function you can find if you do second and then hit 1. Now we have a date. So it says the first date, or date 1, is currently just set at whatever the default is. Then if I scroll down, I have date 2, again, just whatever the default is. Days between, so this is where our answer is going to be. Then if we scroll down one more time, that tells us our day count convention. So let's start back up here at the top. First, I need to type in my first date. So I'm going to type in my first date as the settlement date. So that's going to be August 2nd. So 08, then a period, 02, 22. So the way I just typed that in is month, month, then the decimal, day, day, then year, year. So when I type this into my calculator, I'm going to need to see what I need again, 08, period, 02, 22, then press enter, and you can see now it appears just as a regular date, down. Now my second date is going to be my maturity date. So I have 10, 15, 27, 10, period, 15, 27, enter, down. Now, days between, this is what I'm computing, but before you press compute, make sure it says 360 here. You want it to say 360 because for a corporate bond, this is our convention. If I wanted to switch it, I would do second set, then it switches it to actual number of days. Here we want 360 though, so I'm going to reverse it again. Second, enter, 360, so that's perfect. Scroll back up again, and now I'm going to press compute. So it tells me the days between is 1,873. Now we need to figure out how many full periods that is and how many partial periods. So to get the number of full periods, I'm going to take 1,873 and divide it by 180. The reason I can divide it by 180 is because, again, we have the 360 days per year convention. So in half a year, or in 6 months, we're going to have half of 360. So if I divide this by 180, I get 10.4 and then a whole bunch of decimal places. So that 10 is my number of full coupons. Number of full coupon periods. Now I want to figure out my partial period. So exactly what this number is over here. I like to try and keep as many of the decimal places as I can, so I figure out what the fraction is. So I'm going to take my answer here, subtract off 10, then take that decimal, multiply by 180, so I end up with 73 days. So I'm going to have 73 over 180. That's my partial period. And again, if I divide that by 180, I'm going to end up with that same decimal. So my number of full periods is 10. My partial period is this number down here. So first we're going to start with our full periods. So for the full periods, what we're going to be doing is we're taking all of these full coupons that we're receiving. So I'm going to circle those. And I'm discounting them back one time period. That's the way an annuity works, right? If we have a set of fixed cash flows over a set amount of time, and I discount them back to find the present value, it's going to take them all to one time period before where the first cash flow was. So over here, this is where my 10 payments are occurring. So let's look at our time value of money inputs that we need here. So for step N is going to be my number of full periods, so that's 10. I over Y, that's my R, and I need that to be my semi-annual rate. So I'm going to have 13.51 divided by 2. Present value, that's what I'm solving for. My payment each period is going to be my coupon. So here my coupon rate was 7.5%. So if I have 7.5% of $100 face divided by 2, because they're semi-annual, that gives me $3.75. And then I also want to include that future value here. So I'm going to be discounting back this future value also to that same place on my timeline. So I'm going to put 100 as my future value. So now I'm going to go through and solve for what this present value is. So now when I type these into my calculator, first I'm going to clear the time value of money function. So I'm going to do second future value, second clear. So that clears out my full calculator. Now I'm going to type in each input, and then after I type in each input, I press the key that it's associated with. So I'm going to do 10 is my N. Next up I have I over Y, so I'm going to do 13.51 divided by 2. Make sure you press equals. Then set that as your R. Payment, 3.75 is my payment. Future value is 100. Now I'm going to quit out of that menu, so I do second compute. Press compute one more time. And now that's going to give me what my present value is. So here I have $78.653023. And I always try and keep as many of those decimal places as I can. You can also ignore that negative number there if you want to. The calculator just thinks about them in terms of cash inflows and cash outflows. So it's thinking of you buying a bond today for $78.65. So that'll be a cash outflow from you. Then you're receiving the coupon and the future value. So those are both positive numbers. So that was the full periods. Now what we have to do is the partial periods. So for the partial period, let's just zoom in on this first part of our timeline. So what I've just written out here for the partial period is a zoomed in version of just that first time period. So we go from the last coupon they paid, which would be April 15th, 2022, up until the next coupon they're going to pay, which is October 15th, 2022. And we're currently thinking of settling on this bond August 2nd, 2022. So what we need to figure out is what fraction of a period we would actually own the bond for. And in this case, that's going to be exactly what we calculated up here. That's going to be that partial period. So I'm going to call that variable D. So what I need to do is I need to take both of these cash flows that are remaining and discount them back just until the settlement date, not all the way back. So I'm going to discount them back for a fraction of a period. So if I look at my cash flows here, first for my N, that just needs to be my fraction of a period. Then my I over Y, that's my rate, so that stays the same, 13.51 divided by 2. Present value is what I'm solving for. In this smaller timeline, I don't have any constant payments over a set amount of time, so my payment is 0. Then for my future value, I'm discounting back the price that I calculated before, so the $78.653. And then I still have that last coupon that I haven't included yet. So I'm going to add on $3.75. So I'm discounting back that price that I calculated, from all of my full periods, plus that last coupon that we haven't captured yet. So now I'm going to go through and solve this in my financial calculator. Again, before I actually solve it, I'm going to clear everything out. So I'm going to do second, clear time value of money, second, clear work, and now go through and type in my inputs. Now when I finish, I'm going to do second, compute to quit out, then press the compute button again, lastly present value. So here I end up with 80.247. We'll round that. Again, you'll notice it's a negative number because it's thinking you're buying this bond for $80 and then you're receiving those cash inflows in the future as a positive number. So what you should notice here is that this $80.274 really isn't close to what the Wall Street Journal was saying of $78, right? These two are different. The reason is that what we just calculated is the dirty price. So this is the dirty price. This is the price that you would actually pay if you were buying this bond, because this includes the accrued interest throughout this period, right? So you're paying as if you're receiving that full coupon. Now, the other version of the price that bonds are typically quoted at, as you see in the Wall Street Journal, is what's called the clean price. So the clean price, we have to remove the interest that accrued at the beginning of this period. So again, let's use a zoomed in version of our timeline. I just need to subtract off the accrued interest over this period from my dirty price that I just calculated, and then I get to my clean price. So my clean price So my clean price equals my dirty price minus the fraction of the coupon that was accrued during this portion. So I have the coupon times 1 minus D. So 1 minus D tells us this fraction of the period. So writing this out, I'm going to have my dirty price of 80.247 minus my coupon of $3.75 times 1 minus that fraction of the period, type this all into my calculator. And I'm going to end up with an answer of 78.02. Let's round that. So now we see that this answer that we just got is a lot closer to this clean price that is quoted in the Wall Street Journal. So that 78.02 that we just calculated is going to be the clean price of the bond. So that's going to be what you often see as the quoted price for the bond because it takes out any of that accrued interest. Now, next up, another method that you can use is the bond function. So what's nice about these financial calculators is they have a built-in bond function where you can program in the settlement date, redemption date, price, number of coupons per year, all those sorts of different variables. And it'll give you either the price or the yield or accrued interest, whichever variable you want to calculate. So where you find it is you're going to go second, then 9. And when you scroll through here, you're going to see a whole bunch of different bond inputs. So the first one that should come up is SDT, which stands for settlement date. We're going to plug that in the exact same way we did in the date function. So we're going to plug that in as month, month, period, day, day, year, year. So in this case, the settlement date was 2 business days from when we were looking at this article is what we're assuming. So we have a settlement date of 08 period 02 22. Then I'm going to press enter down. Next up, I need to type in the coupon, and the coupon should be the annual percentage. So the coupon for this bond was 7.5%, so I already have that in here. If not, just retype it in, enter down. The redemption date for this bond is going to be the maturity of this bond, so whenever it matures. Let me fill in the coupon date real quick, or coupon percent, sorry, 7.5. Redemption date is going to be the maturity of the bond, maturity date, and again, same format. So we want month, month, day, day, year, year. So here, it's already in here, but it's going to be October 15th, 27. So 10 period 15, 27, enter down. Redemption value, this is where you type in whatever the face value is at the end of the bond. So just like in the example I did above, I'm going to assume the face value is based off of $100. So here I'm going to put in 100. If you want to use 1,000 instead, you can. So 100, enter down. Next up, you need the day count convention. So here we have a corporate bond. So we want it to say 360. If you wanted to switch it, or if yours currently says ACT or actual, you do second, enter, and that switches. Just switch it back again, second, enter. Rust down. Next up, this is telling me how many coupons per year. So I do have 2 coupons per year. So that's perfect. So I'm just going to do enter down. The yield. So in this problem, we know what the yield is, and we're going to type it in as the annual percentage. So here we're going to type in 13.51%. Again, it's already in there, but I'll just show how to type it in. 13.51. Enter down. And the price is what we want to calculate. So once I'm hovering over price, whatever your last answer is will be stored in there. I'm just going to press compute, and now it gives me an answer. So my price is 78. I'm going to round it to 02. So now what you notice here is that price is exactly the same as the clean price we calculated up above. So the price that the calculator is giving us, this is the clean price. If we wanted to get the dirty price out of this calculation, what we want to actually look at is the next variable, which is called accrued interest. So if I scroll down again, it says my accrued interest equals $2.23. So what that $2.23 is that is this whole term right there. So if I rewrite this out, my clean price equals my dirty price minus my coupon times 1 minus that length of time. This whole coupon times 1 minus the length of time, that is my accrued interest. So I can rewrite this as, I'm going to solve for the dirty price, so my clean price plus my accrued interest equals my dirty price. So here I would end up with $78.02 plus $2.23 equals $80.25. That exactly matches the dirty price that I calculated for this bond, right? If I round that, I end up with $80.25. So now that one becomes my dirty price. So that is how I would use the bond calculator function right above the 9 to calculate the clean price. Then using that clean price, I can add on the accrued interest, and I end up with my dirty price, which is the actual amount of money I would pay if I were actually buying this bond. The clean price is just the quoted price. Thank you for joining me today. I hope you enjoyed this video and you found it helpful. Linked down below, I will have this full PDF of the two sheets that I just wrote out as I was solving this problem using the two different methods. And if you have any questions, please feel free to leave them in the comments down below.